Today we're actually starting a new chapter, and this chapter will give you kind of a basic introduction to a few principles of finance. And so let's look at section 11.1, get you a little bit of help with a few of your homework problems. The first problem that I want to look at is a problem dealing with simple interest. These are the most basic type of interest problems. You see here that we have a formula: interest is equal to present value times rate times time. We can abbreviate that as P times R times T. Now, present value is oftentimes referred to as principal. Rate is always your interest rate. It is in, you usually are given this in a percentage. However, when we plug it into our formula, we need it in decimal form. Time is, we need this in years. And so those will all become factors as we look at some of the problems that you're going to see. So let's talk about this first problem. Calculate the amount of interest earned on $523 at 6.25% simple interest for 3 years. Now, what I like to do is I like to go through and highlight the important things. So $523 is important. 6.25% interest, and 3 years, that's also important. And then finally, this is simple interest, which is going to tell you which formula that you need to use. So all of those things are going to be very important as we move on. So we're going to take our formula, I is equal to P times R times T. We're going to plug the values in that we can. So when we plug that in, P is our present value. Your present value is $523. Your rate is 6.25% interest. Now, remember I said that your interest has to be in decimal form, so you have to convert that to decimal. If you can't remember how to convert that to decimal, you can take 6.25 or 6.25 and divide it by 100. That'll give you the decimal. And then 3 is the 3 years. Okay, and all you have to do is enter this into a calculator and you'll get 98.0625. Now we want to consider this is interest, this is money, and so we want to round to the nearest cent, which means you want to round to 2 decimal places. And so rounded to 2 decimal places, we get $98.06. Now, so that's the amount of interest. So what would be the future value? Let's say that this was a small CD that you put in or something like that. And what would be the future value after 3 years? Well, you can take, a lot of times you will see future value written as A, and that's the amount or the future value, and it is equal to your present value plus your interest that you earn. And so we can plug those in, and our present value was $523. After 3 years, we found that it earned $98.06. So we add those two together and you get $621.06. Now there is an actual formula because you're going to have some problems where it asks you for the future value. You'll notice on your homework you're basically given 2 different kinds of problems, either present value or future value. And so they go ahead and give you this formula that says if you want to find the future value, you can use this formula right here. P, R, and T stand for the same exact things, and I'm going to show you that you could have gone straight from your problem right here, and if they asked you for the future value, you could have used this formula and gotten the same answer. So if we just plug those values in, you'll see that it takes a little bit more calculation here. You have to be careful that you use some parentheses. You'll see that the first thing I wanted to do was I use my order of operations. I do this set of operations first and got the 0.1875. Now I'm going to add these two together, and then I'm going to multiply 523 times 1.1875. When you do that, and you round, you get the same answer. So you got the same answer here as you did up here. So you can go straight to the future value. I just wanted to show you that you can get the future value either way. So you pretty much just pick whichever way makes more sense to you. Okay, let's look at another example. You're going to have problems that ask you about compounding interest. You have different compounding periods in a year. And if you look at this formula, this is going to be written in future value terms. And you now have another variable n, and n is the number of compounding periods in a year. Now, you've probably are familiar with several different types of compounding periods. There are monthly, which would be 12, because there's 12 months in a year. You also have quarterly, which would be 4. There's actually a chart in your textbook that lists out the different common values of n. You have daily, so you have lots of different kinds. So let's look at an example that uses this formula. This is asking for the future value, and again, I'm going to use my highlighter. I'm going to highlight the information that I'm going to need to plug into the formula. So our present value is $795, 6.3% interest. We are compounding quarterly, and this is for 5 years. Okay, these are all my important pieces of information that I'm going to need to plug into my formula. So let's take a look at this formula, and we're going to plug all of these values in. So notice that I did 795 is my present value. I turned my rate of 6.3% into a decimal, and so 0.063, and it's divided by n, which is the number of compounding periods. Quarterly means there's 4 quarters in a year, so that would be 4. That n is repeated up here as an exponent, and then my total number of years is 5. All right, so now again, I'm going to use my order of operations and basically simplify this mathematical operation here. So the first thing I did was simplify that exponent and multiplied 4 times 5 to give me 20. Then I'm going to actually go ahead and simplify what's inside this parentheses, and when I did that, I got this 1.01575. Now what I'm going to do, I'm not sure why I had that repeated again. I apologize for that. But basically, you could plug this straight into a calculator, just like you see this, with using an exponent of 20. And when you round, you get that the future value is $1,086.69. All right, so now we're going to look at present value versus future value. And so you have these two different formulas, and sometimes it's confusing as to which one you need to use. So here again, we're going to look at a few keywords. So this is asking you to find the present value, which probably means you want to use a present value formula. But then you have this interesting word right here that is achieve. Okay, you want to achieve $4,000. Now, to achieve, this is going to be an important amount in 3 years at 3.5%, and this is simple interest, so I'm using my simple interest formula. Okay, so I'm going to go back and I'm going to figure out my simple interest formula. So let's go and pull that simple interest formula. Now, so my simple interest formula, and the reason I used this, I have present value right here, but then I have this word achieve, and achieve means that this is how much money you want. They basically want to know you want to have $4,000 in 3 years. So they want you to find the present value. So in other words, how much money would you have to invest right now if in 3 years, after 3 years at 3.5% simple interest, you want to have saved up $4,000? So I actually need to use this future value formula here. Okay, so let's look at how we're going to use this formula. Notice I kept this as the most simplest type because I am using simple interest. Okay, so basically here I am looking for this P. That's the present value. And that is, I probably should have highlighted that to begin with. I am looking for the present value. And so I need that P. Now, I'm going to go ahead and solve this equation for P. So if you go back to algebra, I can basically, if I can get rid of this 1 plus RT, move it to the other side, then I will have this equation solved for P, and I'll basically have another formula. So that's what I'm going to do. The P is attached to 1 plus RT by multiplication. So to move it to the other side, laws of algebra tell you you need to divide it. And we can divide by this whole thing. So to show you what that looks like is that basically I divided this right side by 1 plus RT, and I divided the left side by 1 plus RT. Now, this is perfectly legal in the world of algebra. As long as what you do to one side, you do to the other side, it's legal. Okay, so what happens here is that these two will cancel each other out. That's that magical number 1 that we've talked about before. And so they cancel each other out, and I am just left with P. And so what I did is I just kind of flopped this around, and I said P is equal to A over 1 plus RT. All right, now this is the formula that I'm going to use. I'm going to plug in all of this information into this formula, and that's going to give me my present value. So I have 4,000, which is the amount that I want to achieve in 3 years, over 1 plus 0.035, which is my simple interest, times 3. I'm going to go ahead and perform this operation in parentheses, and then I'm going to divide 4,000 divided by 1.105, and it tells me that in order to achieve $4,000 in 3 years at 3.5% simple interest, I need to invest this much money right now. Okay, so that's how much money, $3,619.91. All right, you've got some problems that are like this. Okay, now we're going to talk about continuous compounding. Again, we're going to, we need to find the present value. You see this word achieve again. So we're going to be using the future value formula, and I'm going to solve it for the present. I'm going to again solve it for present value. So I want to achieve $250,000, 8.95%. This is compounded continuously. We're going to talk about that. And a really weird 8 years, 155 days. Okay, so a lot of things to talk about here. First of all, when you are compounding continuously, and you're looking at this word continuously, there is a formula that uses the letter E. And anytime you see continuously, you want to use that formula. So this is the formula for continuous compounding, okay? E is one of those, it's one of those numbers like pi that is infinitely long, but it is a standard number, and your calculator has it on, it's programmed into your calculator, into a scientific calculator. If you don't have a scientific calculator, you can just Google free scientific calculator, and one will pull up on Google, so you shouldn't have a problem finding it. P R and T are exactly what we know. A is also exactly what we've talked about. This is the future value. This is the present value. Again, they want us to find the present value. So I am going to, again, solve for P. So I've got to get rid of the E raised to the RT. I'm going to do this the exact same way that I did it last slide. So I'm going to divide both sides by E raised to the RT. When I do that, these two will cancel out and just leave me with P, which is what I wanted. So now I know to get the present value, I have to take my achieved value or future value, divide it by E raised to the RT. So now all you have to do is plug your values into this formula. So it does kind of look funny, and let's talk about this 8 years and 155 days. So if you'll notice here, the 8.95%, that's not a big deal, okay? So that's your rate, and you convert it into decimal form. Now, remember that your time has to be in years. So I know that I have 8 years, but then you also have this 155 days, which is part of a year. So you actually have to convert that into a year. So that's why you see this 155 over 365. That is the part of a year. So I've got to add these two together to get my time. Okay, so I hope that's not too confusing, but you have some problems that use this, and it is confusing to look at to begin with. So now we're going to simplify all of this as much as possible. And so I basically took and I did this in my calculator. I was able to do this all in one big step. You may have to do this in a couple of steps. Sometimes it takes getting used to your calculator to know how to get these steps, but you should get 2.1255 when you do all of this in your calculator. I rounded that a little bit, and so just whenever you're rounding inside of a problem, I know that I'm eventually going to round to the cents. So I always take it out 4 or 5 decimal places to begin with when I'm rounding. So that way you won't turn into have problems. So when you perform this final calculation, you find that your present value needs to be $117,619.38. Okay, I know that was a lot. But hopefully you can look back over this slide again if you've got some questions. Okay, the last one we're going to look at is you've got some questions that talk about inflation. Inflation is just another term for using continuous compounding. And so I just took one of the simple examples here. Find the cost of a cup of coffee, which is currently $2.50. in 9 years, assuming inflation of 7%. So again, you can highlight this is the present value, 9 years, inflation of 7%. Now, inflation is actually an important word because that's what tells you to do continuous compounding. So again, you have your continuous compounding formula. Actually, I don't need to rearrange this formula at all because I want to know the future value. So I don't actually have to do any rearranging. I'm just going to leave it just like this. So I'm going to plug in the numbers. So I plugged in my present value is $2.50. E times 0.07 times 9, E raised to the 0.07 times 9, excuse me. And when you plug all of that into your calculator, it says that in 9 years, your cup of coffee that's currently $2.50 will be $4.69. So there you have your example for inflation. All of the other problems in this section are variations of these problems. So I feel like this should help you get started and help you to go through. You can definitely refer to your textbook and refer to your instructional videos with Dr. Farmer. If you have any questions, please make sure that you give me a shout out on email, and I will be glad to help you with that.